Hey guys, this is a tutorial for the Paper 2.5D setup in one of my previous videos. Unfortunately, I lost that project, so I created a new one, and it's a little more advanced, but it also has the same uh, basically setup that you saw in the previous one. So I have a 3D environment, as you can see, and I got 2D movement, or 3D movement, I should say, but with 2D characters. These are sprites I created myself just for this demonstration. So you got your four directional movement as well as, I guess non-four directional omni movement. And as you can see, there's no, when I move diagonally, there's no floatiness. He steps no matter what. So he like picks a direction and I can move and the animation still plays out. I saw this was an issue in one of the comments on the video. So I'll show you how this is set up. I'm not going to build it from scratch because I tried recording a couple of times and the videos ended up being over hours long. So I'll do my best to explain this one. And whoops, there goes the camera. And hopefully you guys can do this for your own projects. It would be really cool. Also, side note, one of the comments asked if you could get the sprites facing the camera all the time. Well, as you can see, the answer is yes. I will also show how I did that. So let's back out of this. So this is it's a showcase more than a tutorial. This is going to be dealing with stuff that I would say would be intermediate level for the Unreal Engine. So if you're an absolute beginner, this probably will confuse you more than help you, but nonetheless, I hope you enjoy. Feel free to give feedback, critique on me, on my show reel, I guess. So the biggest thing that drives this is my update little section here. So I use a timeline that continuously updates instead of an event tick just to free it up. It functions basically the same, and I have a couple functions. So I'll get back to the camera one, but the update animation one I built. Basically, this is my state machine, I guess. So it starts with getting the velocity of the player. So if it's greater than 0, basically, are you moving? I have a variable, and I hook it up to a function that I called my state machine. Is moving gets fed in. We go inside here. I transfer it over to a local variable, and I branch it off. So you can ignore these parts. This is just, excuse me, this is just for like sprinting and stuff, so it'll double the playback. Anyways, so we'll start with false. So if you're not moving, it'll go over here and it'll return from this variable, this macro. So if we go in here, this is where all my flipbooks are handled. And from what I saw in the comments, a lot of you guys got your flipbooks working. It's just you got stuck at multi-directional input, like you would freeze up. You could still move, but your animations wouldn't play. Well, this section here fixes it. So I use an enumerator. Whoa, go away, Java. I use an enumerator for my animation states. And they have all my states, so idle up, walking up, down, left, right, whatever, right? And what this does is it drives a selector that uses different flipbooks. So if we go back here, if we go to is moving, sorry, if we go back out, I don't think it's set anywhere else. Yeah, I forgot how efficient I made this. Wow. We go back into the state machine. We go to the true side, and it'll assign an animation state based off of the directions. So if we're moving right, it'll assign walking right, left, moving left, up, down, the same thing, and it'll feed it through here. So we come back to this. So is moving. So if we're moving, we have a new animation state. So if it's true, we go down to here, and basically whatever animation state, these are the states, by the way, idle up, walking, idle down, these come from here. And so basically, if the animation state equals idle up, I hooked up the flipbook, the corresponding flipbook from a structure. So I can show you over here. Nope, this is it. Excuse me. I have the enumerator and the flipbooks, right? So the enumerator drives the selector, which drives which flipbook is used, and then it returns it output. And if we go back, it'll output to a simple set flipbook node, which is, you can just search that up. So if you right click and you go set flipbook, that's all it is. And so that's what drives the walking part. So now for the part where the idle animation plays, so I'll show you. So when you're walking, like you guys also might be at a part where you get your walking correctly, but when you stop, he still walks. The part that fixes this is when it branches off into the false. So if you're not moving, the flipbook, it comes back to here. It'll is moving will trigger false. It'll go up here. And a sneaky little thing I did was, because you're still assigned an animation state, right? So if you were walking up and you stop, you expect the character to still be facing upwards, right? Well, that's what this is. So if your current situation is idle up or walking up, which I think in this case it'll automatically assign it to idle up, but just in case, assign the idle up flipbook. We don't even use the walking. And whether or not it knows if you're moving is the moving variable from out here, which is driven by velocity. And it's pretty, like, that's pretty much it. If you set it up this way, a lot of it, like as you can see, I only use one function. Like this right here drives the entire animation. Otherwise, I think that's it. Of course, I added a bit of extra stuff because, you know, in this current scene I have dialogue, NPCs, all that sort of stuff, jumping, but for the sake of the 2.5D character animations, this is what would be all you need. What else is there to show? I think that's it. I had forgotten how efficiently I built this. I'm sure there are other ways to do it, but the biggest thing is create your structure with your flipbooks. I would recommend an enumerator so that you can dictate, you know, what state you're in, because you don't have access to a animation blueprint like you do if you had a mesh. Yeah. If you guys got any questions, feel free to leave them down below. Oh, actually, someone was wondering about the sprite space in the camera. So for that, this is all I did. So you want to get, I got the player controller, get the actor transform, break it, feed in its rotation into a set new or set world rotation of the sprite of the player, and then you add local rotation. So from the camera manager, not the camera itself. I found that caused quite a bit of issues, but the camera manager. And you get the root component, world rotation, break it, and for me I used pitch and then fed it into the delta rotation of the add local rotation, and that's what allows the sprite to always face forward. Now this works for others as well. So if you look, the keys face, the trees face until they break, but as you can see the keys face. All you do is you just copy paste this into another blueprint. I feel like I may have missed some, but I'm not entirely sure. I legitimately forgot how I set this up. It's been quite a while since I visited Unreal. If you guys have any questions or concerns or comments, or if I outright need to do another video to better explain, please feel free to let me know. Yeah, thanks for watching.